we have seen some concepts, or we have seen some basic concepts which may be helpful for our first PUC year. The basic concept which we started here is force. What is it? Force. Force is equal to MA. F is equal to MA. Force is MA. Correct? No? Fine. Now, what I mean to say here is force F is equal to MA. Actually, what is the definition of force? The force means, we can say this one as rate of change of linear momentum. What is the force? Rate of change of linear momentum is a force. Rate of change of linear momentum. What does this dp represent, sir? Final momentum minus initial momentum. Same dt means t2 minus t1. T2 minus T1. Correct? This is what we have seen. And we have seen the force, one force, and another one we have seen the force by the gravity, force by the gravity, mg. Force by the gravity, mg. A body is placed on the table, a body of mass m is placed on a table. Okay? A body of mass m is placed on a table. Some force is acting on it. Mg is a force. This mg force always acts vertically downward. Mg force always acts vertically downward. Yeah, no doubt in it. Vertically downward. Direction is very important. Why? Because force is a vector quantity. It will have the magnitude and direction also. So knowing the direction is very, very important here. Even in the first piece or second piece, directions are much important. Be careful there. Okay, na? So if you observe here, the two forces which I am saying, which we discussed last class is mg. One is a gravitational force we have seen here. Okay, this gravitational force always acts vertically downward. If you take like this, a body is suspended from a rope. Even here also the gravitational force acts here. Mg is acting. If a body is placed on the inclined plane, Mg acts downward. And this we commonly take it as a inclined plane. What's it mean? Inclined plane. Inclined plane. This is inclined plane means having some inclination. This is surface is having some inclination. Like a bus is coming down the bridge. From a bridge, it was coming down. Let's consider the bus is coming down the bridge. Yes, inclination is there. We call this one as an inclined plane. Inclined plane. Okay, even in this also mg acts downward. Even the bus weight also acts mg downward here. Always the mg acts vertically downward. Okay, na? Force, we have seen the two forces here. One is mg. Another one we have seen yesterday, that is n. What is n? Normal force. What is n? Normal force. Normal force. Just we have discussed this. Let us see one more time the normal force means. On a table, there is a table. A block of mass m is kept here. A block of mass m is kept here. When a block of mass m is placed on the table, and we know one force is acting, the force acts on this is mg. mg, right now. This mg acts downward. Okay, you're sitting on a bench, you're sitting in a chair. When you're sitting in a chair, what happens is this mg acts downward here. Means you're applying some force on the bench. Okay, you're standing on the floor, means some force is acting on the floor, that is mg. mg force is acting on the floor. Okay, now? At the same time, I'm saying that this body is at rest means some other force must act like this. Normal reaction. What is it? Normal force. Or some books they write as a reaction force also here. Okay. Reaction force. Okay. Normal reaction. Normal force. We commonly generally take it as a normal force. Right. Now if you are observing the situation, this is one block. Right? This is one block. Okay. This is the block surface. And this bench is also having the surface here. This is the bench surface. Okay, na? Here in this area, these two surfaces are in contact here. In this area, these two surfaces are in contact here. Okay, this is a surface which is where the two bodies are in contact. These are the two surface. This is a surface which is where the two bodies are in contact. For this surface, this normal reaction will be perpendicular 90 degrees. The normal reaction acts perpendicular to the surfaces which are in contact. Understood here? This normal reaction, normal force acts perpendicular to the surfaces which are in contact. Okay, na? These normal reaction acts perpendicular to surfaces which are in contact. So this is a normal reaction. Be careful here. Normal reaction. What's it? Normal reaction. Always it acts normal to the surface which are in contact. For getting the clarity, what I am saying here is, now I am taking the same block of mass m on another surface, means inclined plane. This is the inclined plane here. This is the angle theta. Angle theta here. This is the angle theta. Okay. For this angle, this is the angle theta. On the inclined plane, now I am keeping a block of mass here. Now I am keeping a block of mass here. Okay, now what are the forces acting on this? The force which is acting here is mg. The force which is acting here is mg. Mg is a gravitational force which is acting. And I am saying that one more force is acting. The force which is acting in the world, it is normal reaction. How this normal reaction acts? This normal reaction acts perpendicular to the surfaces which are in contact. See here. They will act here. This is the surface which is in contact for the two bodies here. This is the surface which is in contact for the two bodies. Correct? So this is a surface. This is a block and the inclined plane. The two surfaces here, they are in contact. Correct? They are in contact. Here they are in contact here. For this surface normally acts here. What is it? For this surface, this force acts normally. This is the normal reaction. Okay, now for this surface, this force acts normally. It's a very, very important point here. Okay, now for this surface, this force acts normally. Normal to the surfaces which are in contact. Normal to the surfaces which are in contact here. Okay, now normal to the surfaces which are in contact. So this normal force acts in this direction. Always we cannot say the normal force acts in this direction. Okay, na? Understood here? Okay? Now, I can take one more example here also. I'll try to, 1 second here. Yes. I'm taking one more example here. That is the one which I'm taking. And another one I'm taking here is, this is a wall. Wall. Okay, na? Okay? Just board extension. I am keeping an object like this. This is the remote which I am having here. I am keeping the object like this. Means I am applying the force in this direction. Keep a duster against the board. Means a duster is placed against the ground, means board or like a small block is kept. Here I am applying the force here in this direction. I have to apply the force here. Duster is placed against the blackboard. Okay, we have to apply some force. Yes, I am applying some force here. Just I am applying the force in this direction. Correct? I am applying the force. Here mg is acting here. Normal reaction force. We can call this as a reaction force. That's right. mg is acting here. Yes, reaction force. Here I am applying the force F in this direction, right? F in this direction. Now if you check it, the wall and the block will be in contact. The contact surface is this one. Contact surface is this one. This is the contact surface. Okay, this is the contact surface. Wall and the ball both are in contact. Okay, wall and this body are in contact. This is the surface. For this surface, this acts normally. This force acts normal to the F. Okay, na? See, normal to the surface. Sorry, normal to the surface. Here also, this is a normal here. For this surface, this force is acting normally. Perpendicular. See here, if you observe here, this normal reaction, that's what we call it as normal reaction force. Normal reaction force means the reaction force which is acting normally. Understood here? So normal reaction force. Okay, normal reaction force. So that's what normal reaction force. Here also normal reaction force. And this is normal. Means what I conclude here is normal reaction, as we said, mg acts vertically downward here. Mg acts vertically downward. In normal reaction, we cannot give a direction to the rays. Okay? In normal reaction, we cannot give the direction. Understood here? The normal reaction acts perpendicular to the surfaces. Okay, now upward or in this direction or horizontally also some angle they make. So this is the second force. Till now, I think so. We have discussed two forces here. Okay, now two forces we have seen. One is gravitational force mgm, and another one is normal reaction force. And the one is normal reaction force. And now I'm going to discuss one more force, that is tension. What is it? Tension. Tension is also a force. Tension is also a force. Let's see here. I'm taking this string. This is a rigid support. This represents ceiling here. Okay, rigid support. Okay, very strong. Now, from the rope, a body is suspended. A sphere is suspended with the help of a rope. Okay, with the help of a rope, a sphere is suspended here. With the help of a rope, a sphere is suspended here. Okay, na? Sphere of mass m. Sphere of mass m. Got it here? Sphere of mass m. Now, in a situation, if you observe here, as we know here, the tension, the mg is acting downward. Gravitational force acts downward. Yes. Gravitational force acts downward here. Correct? Huh? Gravitational force acts downward. Here, one force is acting. The force in the string is called as tension. This is a force direction here. Arrow mark represents a force direction. Okay? Nah? The one force is acting. It's a tension. Tension in the string. Some tensional force acts. Tension acts in a string. Okay? Tension in the string. T is equal to mg. T is equal to mg. So this is a tension in the string. This force which acts in the string is a tension. What is it? Is a tension. Always this force acts towards the point of suspension. Means this one. This is the point of suspension. Correct? What we call this one here? We call this one as a point of suspension. Correct? That is a point of suspension. So this is the means this tension always acts towards the point of suspension. No doubt here. Got it? Mg acts vertically downward. Normal force acts perpendicular to the surfaces which are in contact. Whereas here this tension acts towards the point of suspension. What's it? Towards the point of suspension. Understood here? Towards the point of suspension. Okay. This is the one force here which we are having. Okay, so let us see one more example. Let us see here. This body is suspended like this. Okay, here this force is at here also the tension acts here. 100%. Tension acts in this direction. What's the tension direction here? In this direction, right? And this tension, if you see here, this force acts towards here. Towards the point of suspension here. Towards the point of suspension. Always this force, the tension acts towards the point of suspension. Here we have discussed three forces. One is mg, always acting downward, and the one is normal reaction, acts perpendicular to surfaces which are in contact. Whereas the T is the force, tension, which is present in the string. It acts towards the point of suspension. These are the basic some forces may be useful for us here. Okay, ma'am? Got it here? So these are the forces. Okay, now as we seen in the last videos, the last classes, the tension, a vector can be resolved into two components. A vector can be resolved into two components. This component how much? Ax here. What is Ax? A cos theta. And this is Ay. And this is how much? A sin theta. Ax is equal to A cos theta. Ay is A sin theta. Okay, Ay is A sin theta. Understood here? So these are the forces which are means a vector can be resolved into two components. A vector can be resolved into two components. The two components are this: A cos theta, A sin theta. Correct? Na? So these are. So this is also useful for us now for seeing somewhere. Okay? Na? Right. Now what I am going to say is I am going to discuss about the equilibrium. What is it? Equilibrium. Equilibrium means net force is zero. Body will be at rest. Or body may move with a constant velocity. We have the two very important points here. Force is zero. Force is zero means here I can take it as the body may be at rest or moving with constant velocity. Very important here. Constant velocity. Okay, na? A body on the